Whether you follow space news closely or simply came across a few recent headlines, chances are you have heard about the interstellar comet known as 3I/Atlas. This mysterious visitor from beyond our solar system quickly became the center of attention after its discovery in July 2025, sparking excitement within both the scientific community and the general public. Interstellar objects, bodies that originate outside the solar system and drift into our celestial neighborhood, carry an irresistible sense of wonder. They represent untold cosmic journeys, unimaginable distances, and stories of formation processes that took place under conditions far different from anything found near our sun. Because of this, it is no surprise that 3I/Atlas has stirred renewed interest in these rare wanderers and reignited discussions about the nature of interstellar visitors. Only two such objects have ever been observed before: the enigmatic 1I/Oumuamua in 2017 and the distinctly comet-like 2I/Borisov in 2019. The arrival of 3I/Atlas marks only the third confirmed interstellar object in human history, making its discovery a significant event in modern astronomy and a rare opportunity to learn more about what exists beyond our solar system. 3I/Atlas, officially named C/2025 N1 Atlas, was first spotted by the Asteroid Terrestrial Impact Last Alert System in Chile, a program designed to detect approaching objects that might pose a threat to Earth. Instead of discovering a typical comet or asteroid from our own solar system, the team found something extraordinary: an object moving too fast along a trajectory too open to have originated from within our planetary neighborhood. Its speed and orbital path clearly indicated that it was not gravitationally bound to the Sun, and that it had entered our system from interstellar space. The realization that another interstellar visitor had arrived filled astronomers with both excitement and curiosity. Because so few interstellar objects have ever been observed, each one is a unique chance to study how planets and comets form in distant star systems and how material is exchanged between different regions of the galaxy. Although all three known interstellar objects share comet-like characteristics, each has its own distinct story and appearance. When Oumuamua was first detected in 2017, scientists were astonished by its unusual shape. Observations suggested it had an elongated, cigar-like form, extremely unlike the rounded, icy comets typically seen in our solar system. Its lack of a visible tail, combined with its strange acceleration, sparked widespread speculation, ranging from natural explanations to imaginative suggestions that it might be an alien probe. While the scientific consensus strongly rejects such extraordinary ideas, the mystery surrounding Oumuamua highlighted how little we know about interstellar debris. In contrast, 2I/Borisov displayed unmistakable cometary features, including a coma and a tail, which made it easier to compare with normal solar system comets. It behaved as a typical comet would, but its composition hinted at chemical processes from a different stellar environment. 3I/Atlas appears to be more similar to Borisov than to Oumuamua, firmly displaying the features of a traditional comet. Observations indicate that it has a nucleus roughly 1 kilometer wide, approximately the length of 10 football fields placed end to end. This sizable nucleus makes 3I/Atlas larger than both Oumuamua and Borisov, providing astronomers with more material to study and offering clues about the environment in which it originally formed. Whereas Oumuamua lacked a visible tail, 3I/Atlas developed features consistent with cometary activity as it approached the Sun. But what truly sets 3I/Atlas apart is a peculiar behavior that has fascinated researchers around the world. Unlike typical comets, whose tails point away from the Sun because of solar radiation pressure, 3I/Atlas displays a secondary stream of dust that appears to point toward the Sun. While it does possess a faint tail extending in the expected direction, away from the Sun, scientists noticed an additional flow of heavier dust grains being pushed outward in the opposite direction. These grains are too heavy for the Sun's radiation to blow back, yet they move in a way that seems counterintuitive. The explanation lies in the comet's internal activity. As 3I/Atlas warms while approaching the Sun, volatile materials inside it begin to sublimate, creating jets of gas and dust that shoot outward from the surface. Larger particles, unaffected by solar pressure, move according to the direction and strength of these internal jets. Because solar heating intensifies sublimation on the side of the comet facing the Sun, more material gets expelled in that direction, producing the strange effect of a tail seemingly pointing sunward. This unusual behavior provides valuable insight into the physical processes driving comet activity and offers astronomers an opportunity to study cometary jets under conditions unlike those found in our own solar system. Determining the exact origin of 3I/Atlas, however, is much more difficult. When astronomers trace the path it followed into the solar system, they can identify the general direction from which it approached. But this does not reveal the specific star or planetary system it came from. The galaxy is an ever-changing environment filled with stars, gas clouds, and gravitational influences that constantly reshape the paths of free-floating objects. Over millions of years, an interstellar comet can be nudged, pulled, and redirected countless times, making its past trajectory nearly impossible to reconstruct accurately. Even if we attempt to trace its path backward in time, the uncertainties multiply with every gravitational encounter it may have experienced. Still, scientists can make educated guesses based on what they know about comet formation. Most researchers believe that interstellar objects are born within the outer regions of planetary systems, similar to our own Oort cloud. These distant icy realms contain trillions of comet-like bodies that formed from the leftover material of planet formation. Occasionally, a gravitational disturbance, perhaps from a giant planet or a passing star, can fling one of these objects out of its home system entirely, turning it into a rogue traveler drifting through interstellar space. In the case of 3I/Atlas, scientists think it originally orbited a distant star, but was ejected during a close encounter with something massive, likely a large planet or another star in its neighborhood. Observations made with powerful space telescopes, such as the James Webb Space Telescope JWST, and the upcoming Sphere-X mission have provided important clues about its chemical makeup. Measurements indicate that 3I/Atlas contains abundant carbon dioxide ice, suggesting that it formed far from its parent star in a region cold enough for CO2 to freeze. The presence of such volatile ices hints at a frigid birthplace, possibly in a distant outer disk similar to the cold outskirts of our own solar system. These chemical signatures help astronomers compare the formation environments of different planetary systems and understand how common certain building blocks may be throughout the galaxy. Taken together, the arrival of 3I/Atlas offers a rare and valuable chance to peer into the processes that shape planetary systems beyond our own. Each interstellar visitor acts like a messenger, carrying ancient materials that formed under distant stars. With only 3 such objects ever observed, each one is an extraordinary opportunity to learn something new about the galaxy we inhabit. As scientists continue to study 3I/Atlas with advanced instruments and computer models, they hope to uncover even more details about its origins, its composition, and the long journey that brought it here. For now, what we know already paints a vivid picture of a cosmic traveler, formed in the cold outer reaches of a distant star system, flung into interstellar space by a powerful gravitational encounter, wandering for millions of years through the dark between the stars, and finally passing through our solar system, giving humanity a fleeting glimpse of the vast and mysterious universe beyond.